Hey everyone, welcome to Physics at Home today. I thought what I would do is do a hands-on field demonstration. So when we talk about fields, a lot of times you're introduced to it talking about, so for example, around an electron, kind of where do the lines look, and so you'll be introduced with these field line diagrams with things like arrows pointing in, arrows pointing out, and it'll kind of attempt to explain behaviors of why like an electron and another electron don't want to come near each other. And while that works as a model, a lot of times students don't understand the model. And so there's this really great activity that Perimeter Institute came out with that talks about like how to model field lines and how to do other things. And one of them includes a replication of Rutherford's gold foil experiment. So I thought I would try to come up with a way to adapt that experiment so you can bring it home with you and do it from home. So normally it would use this big stretchy fabric, and I'd use a bunch of desks. So today we're using my bed, and then what I've done is underneath here I have generated what we are considering our gold atoms. So you can see here I've got a couple textbooks and a coffee mug stacked on top of each other. And then what you're going to do is you're going to pull the sheet super tight as you possibly can, so that we get just that kind of peak in the middle there. So then essentially what you're going to do is you're going to find a ball. So I've got a little bouncy ball here today. You can use anything that's round and rolls. And the trick is you want it to be smaller than what the mug is. So the mug is representing our gold nucleus. These are going to represent your alpha particles, and what you're going to do is you're going to model what the alpha particles do as they approach the nucleus and hopefully get some experimental results similar to what you would have seen with Rutherford. So tricks to keeping this one consistent and just kind of playing with what I've seen in the classroom. One is make sure you're always throwing from the same side or rolling from the same side. Obviously, Rutherford didn't go from both sides of the nucleus. He just looked at one side, sent the alpha particles, and detected on the other side. So I stay on one side and then look on the other. And then after you throw one or roll one, you can then look at the behaviors, kind of write it down, maybe a sketch on a sheet of paper. In the classroom, we would use chalk to like outline the things, but at home you may not have chalk and don't want to outline your sheets at home, so don't worry about that. So essentially what you're going to do is wherever you want to throw from, just make sure it's taut and get your sheet nice and tight in that site. You're going to take your ball and you're just going to roll it towards the nucleus and see what happens. So you'll see there it went a direct approach and came back. If I were to roll it and not go directly at it or throw less energy, it wouldn't go as far. And then if you go around, then you'll see that it goes straight past and kind of did like an arcing pattern there. So anyways, so there's hands-on Rutherford. I'll link the activity from Perimeter Institute down here as well. You can make the modification as needed and enjoy doing some physics at home.